In this section, we want to learn about complex numbers. Let's suppose that we have x squared equals minus 1. We try to solve this equation. Then you will say that any real number squared will be greater than or equal to 0. So there must be no solution. However, by inventing the complex numbers, we can solve this problem. The imaginary number I is the number that satisfies this equation. So that's the number which is defined as a number whose square is -1, not positive number. So other notation of this I is square root of -1. Let's suppose that b is greater than 0. Then square root of minus b. So minus b is a negative number. Then we have to write it as I times square root of b. What you have to be very careful is with real numbers, the positive real numbers, if a, b are positive, then that can be written as square root of a times b. But that happens only when a and b are positive. When a or b are negative, we always have to convert the number expression as I times square root of b, and b is a positive number. Let's consider square root of minus b times square root of minus b. If this minus b is positive, then we can just combine those by using this rule. But those are negative numbers, so we cannot combine like that because that'll result in b. So that is not true. So when we start to calculate square root of minus b times square root of minus b, we have to rewrite as minus the I square root of b times I square root of b. This I square root of b, I is not sticking to square root of b. That is I times square root of b times I times square root of b. By rearranging, we can understand this multiplication as I squared times square root of b squared. I squared is by its definition -1 square root of b squared is b. So square root of minus b times square root of minus b is minus b. In the following problem, we have to write the given expression in terms of I. Remember that square root of minus b can be written as I times square root of b when b is positive. So this one can be written as minus I times square root of 48. And we have to simplify that. So that is written as 48, 4 times 12. 12 is 4 times 3. So we can rewrite that as minus I times square root of 4 times square root of 4 times square root of 3. These two will make 4. So this one is minus 4I square root of 3. Or we can write it as minus 4 square root of 3I. In this problem, we have to simplify the expression as much as possible. We have square root of minus 30 over square root of minus 10. The numerator can be written as I times square root of 30 over denominator is I times square root of 10. So these two i's will cancel each other, and that's square root of 30 over 10. We can combine those because both numbers are positive. So that is square root of 3. In the next problem, we have square root of minus 3 times square root of minus 15. That is I times square root of 3 times I times square root of 15. So that's I squared times square root of 3 times 3 times 5. I wrote all of those factors under the same radical sign because both are positive. 3 appears twice, so we can take that out in front of square root. So this is 3. What is I squared? I squared is minus 1. So we write minus here and times square root of 5. At the beginning of this lecture, I talked about the imaginary number. Let's extend our notion and we invent the complex number. Complex number is written as A plus BI, when A and B are real numbers and I is square root of minus 1. When we write like this, if B equals 0, then this second term will vanish, so that'll be just A. So when B equals 0, that is a real number. If B is not equal to 0, then none of the term, at least BI, will not disappear. So in that case, we say this A plus BI as imaginary number. Standard form of the complex number is A plus BI, and we say A is a real part and B, number BI, this part as imaginary part. And we also say that A minus BI and A plus BI are complex conjugates. Let's review the number system. The smallest number system is natural numbers. Natural number consists of 1, 2, 3, 4, and all positive countable numbers, and whole number include 0. Integers include negative numbers. So -3, -2, -0, just a 0, 1, 2, and so on. And rational number consists of negative numbers and positive numbers, but it contains fraction and finite decimal form of numbers. So all rational numbers, the rational numbers contains integer and whole numbers and natural numbers. Irrational numbers are the numbers that cannot be represented by fractions or finite decimal form. Examples are square root of 2, pi, e, and so on. If you try to approximate, then the decimal point will go on and on forever. Both rational numbers and irrational numbers will form real numbers. And then we defined imaginary number. Those are I and 1 plus 3i, and so on. Whatever the combination of the numbers are, it contains I. When we include imaginary numbers and real numbers together, we say the number system is a complex number system. In the next problem, we have to add two complex numbers. It's like combining the like terms. We have -3 plus 4i and -5 plus 5i. We add the real number together and the real number together and imaginary numbers together. So we have to add -3 and -5, and we have to add 4i and 5i. Then we will get -8 plus 9i. Here, 4i means 4 times I, and 5i means 5 times I. So those are multiplied rather than sticking together. So we take out I, then we realize that we have to add the numbers in front of I. In the next problem, we have to multiply 2 minus 3i times 6 minus 6i. The working principle will be exactly the same. But the only difference is when we simplify, we use the property I squared equals -1. Let's do FOIL. Then we have 2 times 6 and 2 times -2 times 6i, and then -3i times 6 plus -3i times -6i. So 2 times 6 is 12, and 2 times 6i is 12i, and -3i times 6 is -18i, and -3 times -6, and then we have 2i, so I times I. I times I is minus 1. So we have 18 times minus 1, which is minus 18. So these two terms contain I. So we have 12 minus 18 from this number and this number, plus we take out I, and then 12 minus 18. So we have minus 6 minus 30i. Before we move on to the next problem, we review the important formula. We know that a plus b times a minus b is a squared minus b squared. Let's consider the complex multiplication with conjugate numbers, that is a plus bi times a minus bi. And then by using this formula, we have a squared minus bi squared, which is here. And that means bi times bi. So that's b squared times I squared. This I squared is minus 1. So we have minus b squared. So a squared minus b squared is a squared plus b squared. So this is an important formula. Instead of being a squared minus b squared, if we multiply the conjugate numbers, then it becomes a squared plus b squared. In the following problem, we want to write it as complex number in standard form. That means instead of fraction, we want to write it as a plus bi form. To do that, we have to remove I from the denominator. So we multiply by complex conjugate. So we multiplied by negative 2 plus I in the denominator and numerator. Let's calculate. Then we know that is minus 2 squared minus I squared. So that is 4 minus 1, which is 5. So denominator became 5. And numerator, we calculate by FOIL. Minus 1 times minus 2 plus minus 1 times I plus 2i times minus 2 plus 2i times I. So denominator is 5 and numerator is 2 minus I minus 4i minus 2. So when we add these two, we know 2 minus 2 will become 0. So they will cancel each other. And minus I minus 4i is indeed minus 1 times I minus 4i. So there's minus 1 minus 4i, which is minus 5i. So that is minus 5i over 5. And this 5 and 5 will cancel each other, and we get minus I. This is the final answer.